A pleasant good morning, everyone. My name is Pallapalli Lavati, pursuing MTech first year of branch CSC, bearing with roll number 251FB04030. Today, I am going to discuss about parallel algorithmic patterns using divide and conquer. Parallel algorithmic patterns are one of the most important and widely used patterns that can run on multiple processes. We are implementing using divide and conquer approach here. What is a parallel algorithmic pattern? A parallel algorithmic pattern is a general design used for developing a parallel program. And it describes how computations and data are organized so that multiple tasks can be executed simultaneously. And it also helps the programmers to avoid designing algorithms from scratch so that the development can be easier. By using parallel algorithmic patterns, we can improve performance, scalability, and maintainability using parallel algorithms. Now, divide and conquer. In divide and conquer, a large problem is divided into smaller and similar subproblems. And each subproblem can be solved independently. And the solutions of those subproblems are combined together to get the final result. And this is very suitable for parallel execution. In divide and conquer, there are three main steps involved. The first one is divide. In divide, the main problem is breakdown into subproblems or subparts. And in conquer, each problem is solved independently, often in parallel. And the last one is combine. Combine is nothing but merging the individual results of the final solution. Examples of divide and conquer algorithms. Some of the examples are merge sort, quicksort, binary search, matrix multiplication, and FFT. Merge sort. In merge sort, it divides the array and merges the sorted parts. And the time complexity of this merge sort is big O of and log n. Coming to quicksort, using pivot element, the list of elements are partitioned and recursively sorted. And the time complexity of this quicksort is big O of and log n. Coming to binary search, in binary search, we need to give the list of elements in the sorted order. If it is not in the sorted order, then we need to sort the list of elements using divide and conquer. And later, we need to search for the element that if the given element exists in the list or not. And the time complexity of binary search is log n. Coming to matrix multiplication, in matrix multiplication, true matrices are given and it splits the matrices into blocks. And the time complexity of this matrix multiplication is big O of n cube. Coming to FFT. FFT is nothing but fast Fourier transform, which break down the signals into smaller frequency compounds. And the time complexity of FFT is big O of and log n. Advantages of parallel algorithmic patterns using divide and conquer. The divide and conquer provides high performance for large subproblems by breaking these subproblems into smaller subproblems that can be solved efficiently. And it is easy to understand and implement because since each step follows a simple and logic structure to divide and conquer and solve the problem and combines it. And it is a naturally maps into multi-core and distributed systems where independent subproblems can be executed simultaneously on different processors. And the next step is we need to divide scales the number of scales with number of processors as much of it provides the algorithm. This can be advantage of parallel execution and resulting in improved execution of the program and the performance. Limitations of divide and conquer. Although divide and conquer is a very powerful, but it also has some limitations. One of the major limitation is task creation and synchronization overhead. Creating multiple tasks and coordinating with them can increase execution time. So it may take task creation and synchronization overhead. Now, the combining or merging of results can also be time consuming, especially when we deal with a large number of subproblems. Divide and conquer is not efficient for very small programs because the overhead of dividing and managing the tasks can be greater when compared with the actual computation. Finally, load imbalance may occur if the subproblems are not eventually described among processors, causing some procedures to remain while others are overloaded. Applications of divide and conquer. Divide and conquer is widely used in many real world and computational applications. It is commonly applied in sorting and searching large database, where large amount of data are efficiently divided into smaller parts and processed in parallel. And the next one is it is used in scientific computations. Complex physical and mathematical models are broken into smaller computations that can be solved simultaneously to reduce the execution time. And the next one is image and video processing. These applications use divide and conquer to split the image or video frames into smaller regions, allowing faster processing and analysis. And the last one is it is used in machine learning and data analytics, where large databases are divided into smaller subsets for training, processing, and analyzing, making this approach suitable for high performance and parallel systems. The divide and conquer parallel algorithmic patterns is a very powerful and widely used approach for solving large and complex problems efficiently. By breaking the problem into smaller subproblems, solving them independently, often in parallel, and combining the results, it achieves the high performance, scalability, and simplicity. Because of its abilities to naturally exploit parallelism, divide and conquer plays a crucial role in modern computing system, which includes multi-core processing, distributed systems, and high performance applications. And not but not least, thanks for giving this opportunity to tell about parallel algorithmic patterns using divide and conquer.